Yes, today I'm going to explain the vulnerable time for the slotted aloha protocol. Okay, the vulnerable time for slotted aloha protocol is nothing but it is going to consider the time frame as well as the current time. Okay, means like within that time, how many packets we supposed to send from one device to another device. Okay, this is what. This is what our vulnerable time is supposed to going to consider. Okay, means the device A, like it is going to send the frame to the device B. Okay, the but our device B is already sent a frame between the T minus TR. Like TRF means the current time as well as the given amount of frame time. Okay, see, during that time the collision will be occurs. Okay, because the collision it is going to leads the end of the station B collide with the beginning of the A. Okay, suppose C sends a frame between T and T plus R means our third device, it is going to add it with the first device. Okay, during that time our third device it may be a collision device. Means like whenever we are going to add it with the previous devices. Okay, during that time our data will be overloaded, or our data will be collapsed with the previous data, so that it is going to leads to uh, collision detection method. Okay, the next one is the next one is CSMA means carrier sends multiple access. Okay, what is the carrier sends multiple access? Here, like how why we need this first of all. Okay, like our carrier sends multiple access is nothing but okay, it is going to carry the multiple data or multiple frames in the single channel. Okay, that is what our carrier sends multiple access means. We supposed to access the multiple data within the single medium or a single transition medium. Okay, then why we need this CSMA means to minimize the collision and to maximize the performance. Yes, here we have to reduce the collision. Along with that, we have to increase the throughput as well as the delay and time. Okay, everything we have to increase here. That is what the performance. Okay, here the performance it can contain the throughput as well as reliability and time. Okay, everything. Then, apart from that, our collision can be reduced if stations, like if the device will be sense the medium before trying to use it. Means each station first listen to the medium before sending. Means it is going to check. It is going to check before sending the data. Our sender, it's supposed to going to check whether the particular line or a particular medium, whether it is free or not. Okay, if it is free it is going to transmit the data, otherwise it cannot transmit the data. So this method we call it as a sneeze before transmit or listen before talk. Means first we have to sneeze, it means we have to check it whether the line will be free or not. Okay, if it is free we can chart that the particular line from sender to receiver. Means we have to transmit that particular data from one device to another device. Okay, this method we call it as a listen before talk or since before transmit. Then what is the drawback of this CSMA? The drawback of CSMA is nothing but it can reduce it can reduce the collision. Otherwise, it cannot be eliminate the collision. Okay, it cannot eliminate the collision, but it can reduce the collision. Okay, if collision will be more, okay, it's supposed to obviously it is going to reduce it. Okay, then and as well as it is going to exceed the possibilities of the propagation delay. Means the possibility of the delay it's supposed to be exits. Then the next one is when the station when the device sends a frame. it still take time for the first bit to reach the destination. Okay, if each and every device and every stations to sneeze it means the each and every device it is going to check whether before I am going to transmit the data or frame. Okay, it the given amount of time it is going to check, okay, before whether my data is reached to particular destination or not. So this is one of the drawback. Then yes, a space and time model of the CSMA network. Okay, in that CSMA, that is a main topic. Under that, this is one of the subtopic of that CSMA. That is space and time model. Okay, the space and time model network. The stations are connected to a in a different channel or a shared channel. Okay, a station may be the station may be it is going to sneeze it. Okay, whether the transmission medium it should be ideal or it can be a transmit, it should be a ideal. Okay, if it is ideal, the only because of the first bit sent to the another station, okay, is not had been the received. Okay, means if it is ideal, the particular line or the particular transmission medium, okay, during that time my first bit or first frame I supposed to send to the another station that has not been be that has not received at the receiver side. Okay, then the time t1 station or device it is going to consider as say it is going to check whether the particular line it should be ideal or not. Okay, before sending the data. Okay, if it is ideal or if it is free, they can send the data. Okay, otherwise the collision will be occur. Okay, means if at a time the B station and the C device, B device and the C device. Okay, the device B and device D at a time we supposed to sneeze the particular transmission medium. Okay, during that time, okay, without finding the ideal whether that particular line will be ideal or not. Okay, before knowing that we supposed to send to that particular data to the receiver. Okay, during that time the destroy or collision will be occur. So this is what the space time model of the collision of the sea. This is what the like each and every space. Okay, how much data is supposed to be sent from one device to another. See here all the data will be collapsed, means see the area where the signal will be exits. See another like a B station, the area will be and the signal should be collabed with the A station, B station, and C means all the three station the data will be collabed. Okay, the data will be collision. Otherwise, the data will be destroyed. So this is what the collision will be occur. Then what is the persistence method? The persistence method is nothing but okay before the channel is ideal or busy. Okay, what the device has to do. Okay, if it is busy, like what should the device has to do. Okay, if it is ideal, okay, what the device has to be do. See this is what the persistence method means. We have to take care. Okay, if it is busy, like what kind of steps we have to take care of the devices. Okay, if it is ideal, okay, what I supposed to do for this and during this time what I supposed to do. So every the step means the action should be taken care of the each and every devices. So this is what the persistence method. Okay, the persistence method it can have the three types of method. The first one is one persistence method and non-persistence method and p persistence method. Okay, so we will see what is the step by step what is the one persistence and non-persistent p persistence. Look at this diagram. Okay, this is what the behavior of the three persistence method. Okay, see the behavior is see here it is going if it see here the transmission media. Okay, here busy the media will be busy during that time. Our data or our sender it is going to checking. Okay, whether continuously it is going to checking. Okay, whether it is busy or idle. This is what the first persistent. Okay, this is what the non. Okay, if it is busy, okay, we have to wait for some amount of time. Okay, once that line will be free, then only we can access the that particular channel. So this is what the C persistence. So this is one of the diagram of this, the three persistence